Back with your trusted news and informations. This is the CCSA News Express. Good morning, CCSA. This is Raul Zoran Caracas, and these are the objectives. Explain reasoning and its different kinds and provide examples. Discuss if-then statements and converses and give examples. Elucidate mathematical proofs and provide examples. And discuss how to write a proof. This is the flowchart of our report with the theme Statements, Reasoning, and Proofs, and the title Statements has Reasons that can be proved. The art of reasoning is imperative in mathematics. It is the practice of using critical thinking and problem-solving ability. In this lesson, we will be discussing the different kinds of reasoning such as intuition, analogy, inductive, and deductive reasoning. Additionally, we will be dealing with if-then statements and converses and mathematical proofs. Lastly, the geometric and algebraic properties will be explained, and we will evaluate how to write a proof.
Reasoning is a critical skill that enables students to make use of all other mathematical skills. With the development of mathematical reasoning, students recognize that mathematics makes sense and can be understood. They learn how to evaluate situations, select problem-solving strategies, draw logical conclusions, develop and describe solutions, and recognize how those solutions can be applied. It is a very useful tool in decision-making, but it's not always true. And there are 4 kinds of it. So let's start with intuition, which is also called as reasoning by common sense and is highly subjective. Take note, this kind of reasoning is known or understood without proof or evidence or without understanding how the knowledge was acquired. For instance, if you are asked to differentiate 2 similar objects by identifying the smaller one, you may choose any of them without measuring or without reason when you are using intuition. Or in the statement, love at first sight, this doesn't have reasons. You just conclude that you're in love, so that's intuition all about. Next is analogy, which is a kind of reasoning based on finding a common rational system between 2 situations, examples, or domains. It is a comparison between 2 objects or systems of objects that emphasize respects in which they are thought to be alike. An example of analogy is the tandem between pen and notebook, ball and bat, and many others shown in your screens. Next is inductive reasoning, which is based on observations and not by hypothesis. It starts from specific to general. For example, in describing the pattern in the sequence 1, 4, 16 and predicting the next number, we can conclude that each number is 4 times the previous number, so the answer in the sequence is 64. Another examples were also shown in your screens. Lastly is deductive reasoning, which starts from general or hypothesis to specific. Example, in the statement, each angle of the square is 90 degrees. ABCD is a square, therefore, each angle of ABCD is 90 degrees. Another example using solving and numbers can be shown also in your screens with a clear methods on how it is done. Celine Jane Cabasag, CCSA News Express.
Today, I'm going to discuss the if-then statements and converses. So, let's proceed. What is conditional? It is a statement in mathematics that consists of a hypothesis and a conclusion. The statements are usually written in if-then form. For example, if you watch this video carefully, then you will definitely understand the topic. Let's denote the statement if you watch this video carefully as P, and then you will understand the topic as Q. We can represent it as if P, then Q, where P is the condition and Q is the outcome. If P occurs, then what will be its implication? The implications of the occurrence of P would be the occurrence of Q. So we can write it as P implies Q, where means that when P happens, then Q will definitely happen. So, let's move on to the converse statements. The converse of an if-then statement, where the hypothesis and conclusions of an if-then statement are interchanged, the new statement is called the converse of the original if-then statement. So, we have a statement that if it is raining, then it is cloudy. So, the converse statement of it is, if it is cloudy, then it is raining. And the converse of a true statement can be true or false. This is Bented Lauderos, CCSA News Express.
A mathematical proof is an inferential argument for mathematical statement, showing that the stated assumption logically guarantee the conclusion. So these are may be used as a reasons. The given information or the hypothesis, the definition and undefined terms, the algebraic properties, postulates of geometric, previously proven geometric conjectives are the theorems. So here are the important properties of algebra. For real numbers, w, x, y, and z. So an reflexive property states that in every real numbers there is x equals x. In symmetric property states that for all real numbers there is an x and y. If x equals y, then y equals x. Transitive property states that for all real numbers there is an x, y, and z. If x equals y and y equals z, then x equals z. Substitution property: if x equals y, then y may be replaced by x in any equation or expression. If x plus y equals z and x equals 3, then 3 plus y equals z. Distributive property: if x and then inside the parentheses there is an y plus z equals x, y plus x and z. My name is Manilyn Ann Sayom Lingkitan, CCSA News Express.
Geometric properties. Geometric properties are those that can be derived from the geometry of a solid body or particle. When we talk about the reflexive property of equality, it states that a number is always equal to itself. Reflexive property of equality: if A is a number, then A is equal to A. We use this property to help us solve problems where we need to make operations on just one side of the equation to find out what the other side is equal to. The symmetric property of equality is a simple property that says we can interchange the sides of an equation without changing the truth value of the equation. That is, if A is equal to B, then B is equal to A. Transitive property of congruence in geometry states that if any two angles, lines, or shapes are congruent to a third angle, line, or shape respectively, then the first two angles, lines, or shapes are also congruent to the third angle, line, or to the shape. The addition property states that if you add the same number to both sides of an equation, the sides remain equal, or the equation continues to be true. Solving for equations. For example, to solve x minus 3 equal to 5, we have to add 3 to both sides so that only the variable x will be left on the left side. This implies x minus 3 plus 3 is equal to 5 plus 3, which can be simplified as x is equal to 8. CCSA News Express, Nikki Camarlio.
And now, we will gonna talk about the addition properties of equality, or APE. It states that when the same number is added to both sides of an equation, the equation does not change. For example, if B is equal to D, then B is positive negative to C is equal to D positive negative to C. Multiplication properties of equality, or MPE. It states that when we multiply both sides of an equation by the same number, the two-sided remain equal. For example, if B is equal to D, then BC is equal to CD, or B divided by C is equal to C divided by D. Next one is the definition of congruent segments, or DOCS. It is a segments with the same measure or length. For example, given 1, HI is congruent to JK. Statement 1, HI is equal to JK. Next one is the definition of betweenness. It is a mathematical concept that identifies the quality of a point between two other points on the same line. Given is the letter E, F, and G. And the statement is EF plus FG is equal to EG. Next one is the definition of midpoint, or DOM. It is the point which divides the line segment into two equal parts. Given is Y, M, and Z. M is the midpoint of Y and Z. The statement is YM is congruent to MZ.
Let us move on in writing proof. There are 3 ways on writing a proof. We have the paragraph form, the 2-column form, and the flowchart form. The paragraph form is one way of proof where you write a paragraph to explain why a conjecture for a given situation is true. Now let us move on to the second way of writing a proof, the 2-column form. The 2-column form is the most common way of writing a proof and is one way of organizing proof. This consists of 2 columns, one for the statements and one for the reasons. For example, the given is the measure angle SEP is equal to the measure of angle TER. Now prove that the measure of angle 1 is congruent to the measure of angle 3. To do that, for the first statement, the measure of angle SAP is equal to the measure of angle TER. The reason for that is because it is given. For our second statement, the measure of angle SAP is equal to the measure of angle 1 plus the measure of angle 2. The reason for this is because of angle addition postulate. For the next statement, the measure of angle TER is equal to the measure of angle 2 plus the measure of angle 3. The reason for this is also because of angle addition postulate. For the next statement, the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. The reason for this is because of substitution property. For the next statement, the measure of angle 2 is equal to the measure of angle 2. The reason for this is because of reflexive property. Lastly, the measure of angle 1 is equal to the measure of angle 3. This is because of subtraction property. Let us proceed to the third way of writing a proof, the flowchart form. A flowchart form is where a series of statements are organized in logical order using boxes and arrows. This is Ralph Zorin Caracas, CCSA News Express.